As we get older, our immune system becomes less efficient. This does not only make us more vulnerable to infections, but it also increases the risk of diseases such as cancer, as a major task of the immune system is to find and eliminate pre-cancer cells. This age-driven change in the immune system is the reason why old people are more likely to die from infectious diseases and is a major factor for other diseases, such as Alzheimer's or heart diseases. However, there are things that we can do to slow or maybe even reverse the process we call immunosenescence. And in this video, I want to talk about 4 key research studies that either use the fasting approach or drugs to rejuvenate the immune system. Let's jump right into the first study. When young and old mice received a flu vaccine before being infected with a high dose of the influenza virus, the young mice were perfectly fine, while about 70% of the old mice died. This is a perfect example of immunosenescence. We also see the same in humans, where vaccines are far less efficient in the elderly. But what the researchers found next is fascinating. When the old mice were given a drug called Rapamycin for 6 weeks before the vaccine, none of the old mice died after influenza infection. This magnitude of effect is simply mind-boggling. So let's talk about what Rapamycin does. Rapamycin deserves its own video, but to oversimplify, Rapamycin is an mTOR inhibitor that by inhibiting mTOR signaling induces autophagy. Rapamycin prolongs the lifespan of every organism it was tested on so far. So now we know that Rapamycin is powerful, but how did it so drastically improve vaccine efficiency, and what does this have to do with fasting? Before we understand this, we have to understand what is happening to the immune system during aging. In a nutshell, there are 3 major changes going on while we age, depending where we look. In the bone marrow, where all immune cell precursors are made, we see that the abundance of lymphoid progenitor cells, so the cells of the adaptive immune system, decrease, while the abundance of myeloid progenitor cells increases. At the same time, the thymus, which is the location where T cells mature, shrinks. And last but not least, the T cell population in the periphery shifts to fewer naive T cells and more memory T cells. Now treating old mice with Rapamycin caused a reversal in the shift of immune cell populations in the bone marrow, so it increased the abundance of lymphoid progenitor cells, which likely led to improved immunity after vaccination. This also seems to work in humans. A clinical trial a few years later found that Rapamycin improved immune responses to the influenza vaccine in elderly people based on their antibody titers. Rapamycin treatment also reduced the abundance of memory T cells, which is one of the 3 hallmarks of immunosenescence mentioned earlier. Not only Rapamycin can achieve this, more recent studies showed that fasting could potentially give the same benefits. 2 studies published by the group of Walter Longo found that either prolonged fasting or fasting mimicking diets can also promote stem cell proliferation and increases the number of lymphocytes after refeeding. Not only had the fasting approaches positive effects on the immune system, but they also protected bone mass, reduced inflammation, and increased the median lifespan. Now, reducing inflammation may sound counterintuitive when we talk about improving immunity, but it's actually going hand in hand. Chronic inflammation is often hindering an efficient immune response. And chronic inflammation is also associated with aging and can drive many age-related diseases. So reducing chronic inflammation is actually always a good thing. So to sum up, aging causes a shift in the immune system, which makes it less efficient but causes chronic inflammation. Rapamycin and fasting can reduce or even reverse the shift and thereby boost immunity. The molecular mechanism behind it is not yet completely understood, but it likely has something to do with inhibiting mTOR signaling and thereby inducing autophagy. As always, many things had to be oversimplified, and additional information can be found in the description. Thank you for watching.